Well, hello. So on this one here, we're going to be talking about lesson 5.3, which is locating real zeros of polynomial functions. So locating real zeros of polynomial functions. Now, as always, I wanted to kind of give you a quick rundown what the section's about before we go over questions. One thing I did notice when looking at y'all's homework and stuff, it doesn't actually ask all the questions that we see in the section. But to be thorough, I do want to review everything in the section, and then I'll just focus on just the things that you're being asked on. But if one of these things pop up for you, let me know, and I'll go back and I'll add in some more questions about those topics. All right. So the very first thing that you kind of get into in 5.3 is the rational zero theorem. Now, what I love about when they come up with theorems and you actually read them, when I was a student, it was like, I think they try to find the most complicated way to say it. My goal for you is to take what's already in the book and to break it down in what I like to call more layman terms, where it's a little bit more broken down with our type of language. So, what the rational zero theorem is basically stating, it is going to be all possible zeros that can be found. Let me restate that. All possible real zeros, because it's not going to tell us our imaginary ones. You would have to do a little bit extra math to find those. So they'll tell us all possible real zeros can be found by P divided by Q. The P is all factors of the constant term, and the Q is all factors of the leading coefficient. The next thing you can, and we'll talk about that when we get to those problems. The next thing is the Descartes' rule of sign. And this is one of the ones I saw in your book, but I did not see any questions in your um, homework, which kind of tells me one of two things. One, it'll come up later, or two, this is not quite a standard that you have to know. But if you are a STEMS major and you're planning on taking calculus next, let me go ahead and explain this part so that you at least have some knowledge over it. It just might not appear on your test. But basically, the Descartes rule of sign just tells us how many positive and negative zeros we can have. So if I wanted to know the amount of positive real zeros, all I have to do is count the number of sign changes in the original f of x function. So, so again, amount of positive real zeros, all I got to do is count the number of sign changes. So every time it goes from positive to negative to positive, I just count each time it changes. And then that will tell me how many positive real zeros there's going to be. Then, if I wanted to know the amount of negative real zeros, I'll count the number of sign changes of f of negative x. So if I was to plug in a negative x into the function, simplify it down, and then count those sign changes, that will tell me how many negative real zeros I'll have. Again, they don't really ask this question at all in y'all's homework, so we'll just leave it at that fact until it comes back up, and then I can bring it back up. The next thing, which also it doesn't discuss, is well, I'm going to need more room than that, is the upper and lower bounds of zeros. But again, I'll explain it, but it's not something that seems to be asked upon you. Right? And we see what this says. If I want to know if I have an upper bound in zeros, meaning when we determine how many potential zeros we have, and you'll see in a later example, I could have possible zeros being like 1, 2, 4, 8, 16, 32, or something like that, right? And I could determine, well, maybe I don't want to find out if 32 is a zero or not. So I can do 16, and I'll show you how to do this as well. We'll be using synthetic division like we did in the last video, but I could do 16, and then I can look at the answer that I get from my synthetic division. And if there are no negatives, then I can say, you know what, 16 is an upper bound, meaning that 32 is not a zero, right? So what that helps me do is I can pick a number and go, all right, is this the largest value or do I need to go higher? Because by doing 16, I can cancel out 32. But let's say now I want to do 4. I do 4 and I find out, hey, you know what? 4 has no sign changes either, or sorry, no negative numbers. And then actually 4 becomes, and now I can delete 8 and 16, even though I've already done 16, unless I got the value of 0, then 4 wouldn't work. But I can kind of go through that process. And what it does, it allows me to eliminate some of the math by just determining, hey, is this an upper or lower bound? And what's great about doing this is you're looking for answers anyways. So by determining your upper lower bounds, it's not adding any more work. If anything, it's actually deleting work for you. So even though it's not asked upon you to do it, we can actually utilize it to help us find our answers as well. So it doesn't ever ask you flat out, hey, is this an upper or lower bound? But with this fact, will help us save some time by just paying attention to the answers that we get. So again, to determine if something's an upper bound, that basically means there are no real zeros larger than B. We'll call B that zero that we're trying. By using synthetic division, the Q of X, basically the answer that we get on the bottom of our work, has no negatives. And if it has no negatives, I know that that is there's no number higher than it. So I can delete any number that might have been an option for higher. So I'll explain more with that when we do a actual example. Lower bound, same concept. When we look for potential zeros, each potential zero is a plus or a minus. So it could be, let's say we go back and I said 1, 2, 4, 8, 16, 32. Well, technically it's plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 16, plus or minus 32. There's a whole bunch of options for this potential one I just made up in my head. But if I wanted to, I could just do -8 and go, all right, is this a lower bound? Is this a situation where I can go ahead and delete -16 and -32 because nothing's lower than -8? I'm not saying -8 will be a zero, but depending on how the signs come out, I can tell you if there is a zero that's less than -8. And what you'll be paying attention to is alternate signs. So if your Q of X changes signs repeatedly, then it is a lower bound. If you get like negative, positive, negative, negative, even though it was changing, but there was just one moment it didn't, not a lower bound. So that means there's a number that's lower than it. So by choosing -8, I get to determine two things. Can I delete -16 and -32? Or if it's not a lower bound, then it must be either -16 or -32 that is my lower bound. Right? So again, that would be no real zeros larger, or sorry, less than, not larger this time, less than B. And again, we're going to be using that synthetic division where the Q of X alternate signs. Right? So again, in your homework, it doesn't ever ask you specifically, hey, is this potential zero an upper or lower bound? But we can use this knowledge to help us find the answers, because in your textbook, you are asked to find all the zeros, and you do this without a graphing calculator. So you would have to have all the work to justify your answer. The last thing it talks about is the intermediate value theorem. And this one, it does ask you a lot. And there's actually a pretty big topic in Calculus 1. So definitely a topic to pay attention to. Now, when I usually teach this, intermediate value theorem actually comes up in high school, like in Algebra 2. And I call it the common sense theorem. And I'll express it orally, and then I'll put it down on paper as well for you. But basically, what the intermediate value theorem states is if you have a value A that's less than value B, meaning A is less than B on a continuous number line, and you plug it into this function and you get a value that's negative and a value that's positive, then at some point, zero had to be in between that. And it has to be a continuous function, right? So this basically states if the function is continuous, and we're looking primarily at polynomial functions, and all polynomial functions are continuous, but this can be applied to other functions like square roots and logarithms, as long as it's continuous in a interval. So it basically states that the function is continuous in a closed interval a b. So it basically states the function is continuous in a closed interval a to b, where a is less than b and a is less than c, which is less than b, and f of a and f of b have different signs, meaning one's negative, one's positive, then there is a C in which f of C equals zero. And again, basically stating is as long as there's a continuous line and you have one that's negative, one that's positive, at some point it had to go through the x-axis. Now I'm just saying at some point. Now I'm not saying they didn't go through it multiple times, but it had to go through at least one time. And this is something that your homework definitely does ask you multiple times on how to do this. So with all that, that's pretty much the rundown of what 5.3 is. Let's jump into some actual examples that you'll see on your homework to help you practice. So in the first example, we're going to look at number 2. And in this first portion, it says list all the potential rational zeros of the following polynomial, then use the polynomial division and the quadratic formula if necessary to identify the actual zeros. All right, so this is how we do it. So you have what we call -2x cubed, or I guess, sorry, g of x is equal to -2x cubed plus 11x squared plus x minus 30. So possible zeros is P divided by Q. P is all the factors of the constant. So let me do this differently. I'm going to do P here, and then I'll do Q here. P is going to come from the constant term, which is typically the last term. But if there's no constant term, meaning maybe it just stopped at X, then this part we can't continue. It has to have a constant term. In this case, it's negative 30. Now we're just going to look at the absolute value of that. So I'm just going to look at the absolute value of 30. And I'm going to think of all the factors of 30. There's 1, there's 2, there's 3, 4 does not go into it. There's 5, there's 6, and then you can kind of go this way. So 5 times 6 is 30, and then 3 times 10, 2 times 15, and then 1 times 30. So trying to kind of figure out the rest of them, you don't have to like do 7, 8, 9, and 11, 12. Once you get to this point where you're like, all right, I know 1 goes into 3, 5, 6. Oh, these two are what's multiplies to 30. Then you can kind of go this way. And we're going to divide that by all the factors of the leading coefficient, which again is the coefficient that's in front of the highest degree. All right, so that -2, again, we're going to look at the absolute value of all the factors that go into 2. And in this case, it's 1 and 2. So this is what you do to find all possible zeros. We're going to take all these numbers, divide it by 1. And obviously, it'll be all those numbers. So it'll be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 5, plus or minus 6, plus or minus 10, plus or minus 15, plus or minus 30. Now I got to divide those all by 2. So I run out of room, so I'm going to do plus or minus 1/2. 1's already been used. Plus or minus 3/2. Plus or minus 5/2. 3's already been used. 5's already been used. Plus or minus 15/2, and then 15's already been used. So those are all the possible zeros that this could have. Now, the next thing is trying to determine which one is a 0. If we can just guess 1, the rest of it is relatively straightforward. How you go about doing this is really completely up to you. I usually just start here and I just progress my way through it, unless it's something I can easily see. And really and truly, if it's something above a quadratic, I am not so easily seen to do it. But really the goal is which one of these will give me a remainder of 0. So I'm going to start with 1 and kind of progress through. But this is where we can use that upper and lower bound. So if you wanted to, you're like, all right, I want to try 6. If 6 gives me no negative numbers, then I can go ahead and delete 10, 15, and 30. All right, so that's kind of the concept. So what I can do here is I'm going to start with 1, but if 1 gives me non-negative numbers, then I can say, hey, that's an upper bound. Let me try 1/2 next. If I was to go in the negative direction, and I do -1, and I go, hey, this gave me alternate numbers, I can delete everything else and try -1/2 if I wanted to. So there's different kind of things you could do. So I'm going to try 1. That's the pattern I go with. And then I'm going to use synthetic division. So x cubed is a -2. X squared is 11. X is 1, and my constant is -30. The goal here is to just get the remainder of 0, but if I don't, let's also pay attention to the q of x sign to see, does it help me eliminate any other options so I can go a different direction? Now, the other thing is a cubic, so there is 3 potential zeros in here if they're all real. If there's some imaginary, I'm only going to have 1 potential answer here, and the other 2 are going to be imaginary. So there's always that to kind of play around with. So we always hope we get it off the right foot. There's no other easier way to do that, though. So I get 1 times -2 is -2. 11 plus -2 is 9. 1 times 9 is 9. 1 plus 9 is 10. And then 1 times 10 is 10, so I get negative 20. All right, so 1's not a 0. I'm going to pay attention to my signs. Oh, I have a negative, so 1's not an upper bound. That means there's something better, bigger than 1. And they don't alternate because it went negative, positive, stayed positive, so 1's also not a lower bound. So what I do is I just put an X to show that that's not my result, and it doesn't eliminate anything else. So now I just move on to the next number. So I'll try a 2. And so concept is still the same. So negative 2, 11, 1, negative 30. Break it down. Don't forget that first step of dropping down that number. So 2 times negative 4 is negative, my bad. 2 times negative 2 is negative 4. 11 plus negative 4 is 7. 2 times 7 is 14. 1 plus 14 is 15. 2 times 15 is 30. Negative 30 plus 30 is 0. Boom, 2 is an answer. So that means x equals 2 is an answer. Then what we can do from here is we can figure out what this answer is. So this would be x squared plus x plus 15. And what we can do with that is now when it becomes a quadratic, we can factor it, either factor or use the quadratic formula. So that's what I'm going to do real quick. I'm going to go, all right, so if I quickly do AC here to see if it's factorable, negative 2 times 15 is negative 30, and my B is 7. I got 1 and 30, 2 and 15, 3 and 10. Okay, 3 and 10, that would give me negative 30 if I make that a negative. So therefore, I would get x minus 3 and x plus 10. That would multiply to negative 30, add up to 10, but I have to divide by my a. So I'm going to divide by negative 2. And when I do that, I get a positive, but then the 2 has to go to the front. So I get a 2x plus 3. And then this will give me x minus 5. Oh, I see. Because it's a negative, I think the rule is you have to multiply by a negative, but it's not going to be a big deal. So we can do x minus 5, and we just got to multiply one of these by negative. So I'm actually going to just do this, negative x and a positive. That right there will give me my negative 2x squared, my positive 15. That will give me negative 3x, and then a positive 10 will give me a positive 7x. So you can multiply either one and it'll work out for you. But I just went with this one because it was easier. All right, so with that, I can then take each factor, 2x plus 3 equals 0, and negative x plus 5 equals 0. So this will give me 2x equals negative 3 by subtracting 3, and x equals negative 3 halves. So I could have used a fraction to get my answer. The next one would be negative x equals negative 5, and then positive x equals positive 5. So I could have gotten to 5 and then had to produce an answer of 2. So my question is here's all my possible zeros. This is part of your answer. And then part 2 of your answer would just be x equals negative 3 halves, 2, and 5, the actual zeros. All right, so that's kind of the process that we can do. So let's do a whole lot more so that we have a full understanding of what we're doing. So let's look at example 3. So this one is P of x equals x to the fourth minus 5x cubed plus 10x squared minus 20x plus 24. So my possible zeros are going to be all my factors of 24. That's going to be 1, 2, 3, 4. 5 does not go into it, but it would be 6. So 4 times 6 is 24. So that means then that 3 times 8, 2 times 12, and then 1 times 24. So once I find that middle number, I can just go this direction with it, all divided by all the factors of 1. So luckily for me, it's just plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, and plus or minus 24. All right, so I'm going to do a little different here of a direction to do it to try to determine what my answer is. And I'm going to try to find a number in the middle. And let's go with 4. It doesn't really matter, I guess, which one you go with, 4 or 6. But I think it's closer to these numbers. It could be these numbers. I really don't know. So I'm going to choose 4 as my possible go-getter, because what I'm going to have to do is I'm going to have to do synthetic division twice. So if I can eliminate a lot of these, that'd be great, because the goal is to get it down to a quadratic. All right, so here we go. So x to the fourth would be 1. X cubed would be -5. X squared would be a 10. X would be -20. And my constant would be a 24. So 4 times 1 is 4. -5 plus 4 is -1. 4 times -1 is -4. 10 plus -4 is 6. 4 times 6 is 24. -20 plus 24 is 4. And then 4 times 4 is 16. And then 16 plus 24. I do that right? Hold on. 1, -5, 10, -20, 24. 4. Yep. 6, 24, positive 4, 16. So this would be 8. All right, so we go. So then that would not be 1. And it did not tell me anything. So it's not an upper bound. It's not a lower bound. So I have to choose a different value. So let's try. Let's try 6, I guess. So if I try 6, now I'll go to 3 and then go back and forth here just from the middle. All right, so 1, -5, 10, -20, 24. That give me, that's an arrow. That'd be 6, 1, 6, 16. So that's 60, 96, 76, a really big number, which will give me a really big number. Obviously, this wasn't a 0. However, I noticed that all of them are positive. So that tells me 6 is an upper bound. So that means I can actually, I've already tried +4, so that's out. I just tried +6. It was way out, some really big number. But because I had all positive numbers, I can now eliminate +8, +12, and +24, because there's no number that's going to be larger than 6 that's going to be a 0. My 0's got to be less than 6. It has to be less than 4 too, because I've already tried 4. So I'm going to go to 3. But see how that one information, even though I didn't do any extra work, I paid attention to my upper and lower bound rules, and I was able to eliminate 3 more options. And now it purposely takes me to 3. So again, even though you're not being tested over upper and lower bound, just knowing that fact can definitely make our lives a little bit easier, because this job does get a little bit tedious when trying to find your answer. So let's go through it. So that's going to be, it's going to be a 1. That's going to be 3. That's going to be a -2. That's going to be a -6. That's going to be a 4. That's going to be a 12. That's going to be a -8. That's going to be a -24. Look at that. Got a 0. So by eliminating those, I didn't keep going further. I was able to come over here. So 3 is definitely a winner. So x equals 3. But the issue is this is now a x cubed plus -2x plus 4. Oh, sorry, -2x squared plus 4x plus -8. I still have a cube. So I have to do this again, but I can use these numbers to try to determine another number. So let's see. Let's try to think about the lower bound aspect of this. Actually, I think I'm just going to keep going this way. But if I could go to like -6 and try to see if that's a lower bound, or -4, something like that. But I'm just going to keep the pattern going because I was able to eliminate so many positives. But that's what you could do if you want. But here we go. So that's going to be a 1, a -2, a 4, and a -8. So those are my values that I just got, and I can use those. And it'll actually, if this is a factor of this, it'll be a factor of this big one. So here we go. That's 2. That's 0. That's 0. That's 4. That's, hey, look at that. That gives me 0 as well. So x equals 2 is good. I'm glad I didn't do a negative. So I was about to say, if this doesn't work, I'm going to go to a negative. But I was just trying to eliminate all my positives. All right, so that means I just got 2 answers. And I'm now left with 1x squared plus 0x plus 4. So really, I'm left with x squared plus 4. This is something that I can easily solve. I can just set equal to 0. So x squared equals -4. Take the square root, and I get x equals plus or minus, pull out the I, and then square root of 4 is 2. So my answers are plus or minus 2i, 2, and 3. So this is your first part of your answer, and then this is the second part. So it's probably why they didn't go into a lot of questions here, because just the first part can be so long. All right, but again, I want to make sure that you understand. So again, we're going to do example 4. So h of x is equal to x cubed minus 3x squared plus 9x plus 13. So all my factors of 13, hey, is 1 and 13, and all my factors of 1 is just 1. So these are the questions you hope for on the test, right? So this is going to be plus or minus 1 and plus or minus 13. So you can go any direction you want with this. I generically, again, I start at 1. Doing an upper bound situation here, not going to really tell you much because it's just going to eliminate that 1 if that's an upper bound and not do anything else. But if I do get an upper bound for 1, I can eliminate 13 and then potentially just do negatives. So I'm going to do 1 here. All right, so my x cubed is 1, x squared is -3, x is 9, and my constant is 13. I always have kids ask me this once they fully grasp this concept. Do I have to write this out? No. I do this for organization purposes so that you can see I have a coefficient for everything. And when I write my answer, I can decrease by 1 degree. If you get it without looking at it, by all means, do that part. But as your professor, I like to give you as much organization as you need. So 1 times 1 is 1. -3 plus 1 is -2. 1 times -2 is -2. 9 plus -2, oh, what is that? 7. 1 times 7 is 7, and then that's 20. All right, so looking at that right there, I just determined that 1 is not a 0. And I almost want to say, man, this is also a lower bound, but it has to change all the way through. So positive, negative, positive. If this would have been a negative number, I could have said 13 is my answer because that 1 would have been a lower bound. But 1 doesn't tell me anything, so I eliminate it. So I'm going to try a -1. All right, so now I'm going to do 1, -3, 9, 13. Really, I usually go up to the next positive, but I'm just trying to avoid having to multiply by 13. So I'm really hoping this is it. This is -4, 4, 13. Ah, very good. So 0. So -1 is an answer. And this right here would be x squared plus -4x plus 13. So again, clean that up. That's x squared minus 4x plus 13. And I'm going to try to see if I can do this the AC method. So 2 things that multiply 13 but add to -4. 1 and 13 is my only options, and it doesn't give that. So we're being forced to use the quadratic formula. Again, if you've forgotten it, -b plus or minus square root b squared minus 4ac, all divided by 2a. So here we go. So this is going to be, again, if you have to label it, do so. A, B, C. A is 1, B is -4, C is 13. All right, so that's going to be -4 plus or minus the square root of -4 squared minus 4 times 1 times 13. Again, use those parentheses to help separate your information, and then 2 times 1. So that's going to be 2 negatives make a positive, plus or minus 16 minus 4 times 1 times 13. 13 times 4 is 40, 52. So minus 52 over 2. 4 plus or minus, oh man, I want to say 36. 52 minus 16, good. -36 over 2. So this gives me 4 plus or minus, I'm going to pull out the I, square root of 36 is 6, divided by 2, but it's an A plus B format, so that would be 4 over 2 plus or minus 6i over 2. Running out of room, so this would be 2 plus or minus 3i. So there's my answer. So I get x equals 2 plus or minus 3i, and negative 1. There you go. Yes, there is possibility that all of them are imaginary. And I hope you never get that question because you'll be on it forever, but you have to draw the conclusion after you've done all of the work. All right, let's do another example. Yeah, I want to give you plenty. So let's look at 5. Q of x is equal to x cubed minus 10x squared plus 23x minus 14. So my p divided by q is plus or minus, oh, well, it is, but do this first. So 1, 2 goes into 14, 3, 4, 5, 6, 7, and then 14. There we go. And then just 1. So this gives you plus or minus 1, plus or minus 2, plus or minus 7, plus or minus 14. All right, again, we just kind of go through the regressions. I'm going to start with 1 and then kind of go from there. So 1, again, x cubed is 1, x squared is negative 10, x is 23, constant is negative 14. So here we go. What is that? That's going to be, ooh, that's 14, I believe. Yep, and then that gives you 14. Ooh, that gives you 0. All right, perfect. So that means then that I have x squared minus 9x plus 14. Because again, this would be x squared plus x plus 14. And so again, I'm going to try to see, all right, what multiplies to 14 that adds to negative 9, 2 and 7, both negative. So that gives me x minus 2, x minus 7. That would give you positive 14, and then negative 9. So therefore, x would equal 2 and x would equal 7. So my answers would be x equals 1, 2, and 7. Don't forget the first 0 that started you the process. All right, so let's just do one more and then I'll move on to something else. So let's look at example 6. This one says r of x equals x to the 4th plus x to the 3rd plus 23x squared plus 25x minus 50. Okay, just to speed up the process just a little bit, obviously I'm going to be dividing by 1, so this is going to be plus or minus of all the factors of 50. So plus or minus 1, plus or minus 2, because 2 goes into it 25 times, 3, no, 4, no, 5, plus or minus 5, 10 times, and then 6, no, 7, no, 8, no, 9, no, and then so it'll be 10. So 10, and then this would be 25, and then this would be 50. There you go. So we quickly got the answers. Let's see. Again, go with any process you would like. I'm going to start with 1. So again, x4 is 1, x cubed is 1, x squared is 23, x is 25, my constant's negative 50. Hey, I like it when it works out. That x equals 1 is an answer. The only issue is we're still just at a quadrat or cubic. So I need to find a different one. So let's see. Process. Well, you know what? 1 gave me a 0, but pay attention to this right here. Notice they're all positive. So that tells me that that is a upper bound, which is great news because I can now eliminate. So 1 was correct. Positive 2, positive 5, positive 10, positive 25, and positive 50 are now out. So I was trying to think, do I want to go 2? Do I want to go negative 1? But this is all positive because you always want to see if you can pull some information from it. So I'm going to go negative 1. What's that going to give me? So 1, 2, 25, 50. So again, I can use my new numbers. No, not quite. So that'd be negative 24. And then that would be a 26. I do see that it's all positive, but that would tell me it's an upper bound as well. But I know that's not true because that's a 1. So interesting that that does that. Hmm. Hopefully that didn't backfire and I eliminate one of my answers. But there's nothing greater than -1 either. So, but 1 was. But I'm glad we used it because we started with -1. I would have already deleted it. All right. So interesting chain of events there. Let's try -2. If all those end up being, I'll have to go backwards, but kind of strange. So 1, 2, 25, 50, -2, 0, 0, 25, -50. Hey, look at that. And I get 0. So x equals -2 is an answer. So good. That part can't lie to me. This part was kind of curious. So that right there would be a x squared, and then that would just be an x. So this would be x squared plus 25 equals 0. X squared equals -25, so therefore x equals plus or minus 5i. Because again, I'll take the square root and then just pull out the I. All right, so my answers are plus or minus 5i, -2, and 1. There you go, plus this part here. All right, so I think that's enough examples for you. So I want to move on to that next section, which is number 15. Or example 15, or however you want to look at this. So on number 15, it says use the rational zero theorem, which is basically what we kind of been doing, on your answers to the preceding problem and solve the following equations. Oh, wow. Okay. So we already did this. Identify the actual zeros. So number 4. Okay, yeah. So we actually already did this. Is the result to what's that, number 4? Yeah. So I won't do it again. So basically, I think on some of them, it was just asking for the possible zeros, and then some of them was actually go another step. So I think that's where I got that question in. But we already did the work, so I went ahead and solved it. Alrighty. So let's jump to a different type of question then. Let's look at number 57. So again, that's what I'm saying. It didn't really ask any specific lower bound, upper bound, or sign changes as well using the Descartes rule. It just kind of jumped right into intermediate value theorem, and it's basically just stating, hey, is this interval, is there a zero between it? And it's super easy. It's way easier than what we've been doing. I say what we were doing was hard. It was just a lot. But on number 57, it says f of x equals 5x cubed minus 4x squared minus 31x minus 6. And we're trying to determine, is there a zero between -3 and 1? All right, so polynomial functions are continuous. That is the first thing you have to determine. Is your function you're dealing with continuous? Every function you're dealing with right now is continuous, but we'll get to a point where we're not dealing with polynomials, so we have to check that. But for now, we know it is. So basically, all you have to do here is determine what is f of -3. If I plug in -3 and 1 and I get different signs, then I know there's a C in which f of C will equal 0. And again, that's all it's asking. Use the intermediate value theorem to show that each of the following polynomials has a real zero in between it. So here we go. So this becomes 5 times -3 cubed minus 4 times -3 squared minus 31 times -3 minus 6. So this gives you 5 times 3, 9, -27. 4 times 9 minus 31. I'll keep it like this. Let's do it all at once. 5 times 25, that's 5 quarters. That's got to be like 130 or something, right? 27 times 5, 135. All right, so that'd be -135 minus 36 plus 93 minus 6. Right. Okay, so just make sure we don't mess up. So let's do 135, make it a negative, minus 36 plus 93 minus 6. So that gives us a -84. So now I'm going to do f of 1. And as long as I get a positive number, it's true. The intermediate volume theorem states there is a 0, at least a 0. It could be multiple times, but it has at least a 0. Now, also another thing to note, if I was to get a negative, it's not saying that there's not a negative in there. A 0 in there. We just can't use intermediate volume theorem to prove it. So like if I got negative 84 and I got like -1, but then when I graphed it, I'm like, it does go through it. Well, it might, but we just couldn't use the intermediate volume theorem to state that. So just watch out for that when you're working through these problems. So this is going to be 4 times 1 cubed minus 4 times 1 squared minus 31 times 1 minus 6. So that's 5 times 1 minus 4 times 1 minus 31 times 1 minus 6. 5 minus 4 minus 31 minus 6. What's that going to be? 1. 1 minus 31 is -30. And then that's -36, correct? That would be correct. However, the directions ask you to find it between -3 and -1. So let me try that again. -1, -1, -1, -1. This will actually mean -1. That's true. This will stay -1. This is not true. So this will be -5, -4, +31, -6. So this will give you -9 plus 31. -9 plus 31 minus 6 gives you 16. So yes, intermediate volume theorem does work. Had it been 2-1, we could have said no. But you might be asking yourself, like, if it works between -3 and 1, why did it not work? Well, so if it didn't work between -3 and +1, how did it work between -3 and 1? And again, just because they don't have different signs, it doesn't mean that there's not a 0. It's just we couldn't use intermediate volume theorem for that large of an interval. When I actually put the correct interval of -1, then we can use intermediate volume theorem and state, yes, there is at least 1 0 there. All right, so let's do another one of these types. This will kind of wrap us up as well. So we'll do 59. And it says f of x equals x to the 4th plus 2x cubed minus 10x squared minus 14x plus 21. And we're going to look at the interval 2 and 3. I'm going to make sure I wrote it right. I did. Okay. So here we go. So simple math, we're just going to plug it in. So 2 to the 4th plus 2 times 2 to the 3rd minus 10 times 2 to the 2nd minus 14 times 2 plus 21. That's 2, 4, 8, 16. This is going to be 2, 4, 8. This is 2, 4. Again, you can do a lot of these steps and skip them. I'm good with that. As your instructor, I just want to make sure you got it down. All right, so 16 plus 16, 32. 32 minus 40 is -8. -8 minus 28 is -36. -36 plus 21 would be -15. Okay, so then we're going to try f of 3. So that'd be 3 to the 4th plus 2 times 3 to the 3rd minus 10 times 3 to the 2nd power minus 14 times 3 plus 21. So 3, 9, 27, 81. 2 is 27. 9. 54, -90. 14, 28, 42. All right. Oh, trusty little 4 little calculator. All right, so 81 plus 54 minus 90 minus 42 plus 21. So that's going to be 24. So therefore we can say yes, because again, we got a negative and a positive. All right, so let's do another type of this question, but just looks different. So number 61, it says, show that each of the following equations have a solution between the indicated reals, but it looks like this. So same question, this looks different. So it says 14x plus 10x squared equals x to the fourth plus 2x cubed plus 21. And we're looking for the intervals between 2 and 3. All right, so what we want to do here is we actually want to set this equal to 0 and then put it in the correct standard. So I'm actually going to subtract 14x and 10x squared over, and then rewrite it in the correct order. So I get 0 equals x to the fourth plus 2x cubed minus 10x squared minus 14x plus 21. So that's the only difference you got to do. And now all I got to do is just plug it in and then just determine like what is my values at 2 and 3. So I'm going to change it now to f of 2. And I'm going to go 2 to the fourth plus 2 times 2 cubed minus 10 times 2 squared. And we already did this one. I'm about to say these numbers looked real familiar because I feel like I just did it. When we just did this problem on number 59. Okay, so, and we already know that answer ended up being 15. And then you also already know that f of 3 is, what was it? Negative 24. So again, this was a yes as well. So I didn't realize I was going to do that. That's twice now. I just pulled from a different question. All right, so this last one, number 62, is actually just like number 60, but we didn't do 60. So this one will have to go all through the process. So I'll give you, this will be our last one. So that's x cubed minus 2x squared equals 13 times x minus 2 from the intervals of -4 and -3. So here we go. That's x cubed minus 2x squared. And if I distribute this, that would be 13x minus 26. So to save ourselves some time, I subtract it over. That gives me negative 13x plus 26 equals 0. So I just moved them over as well. Now I can go find f of -4. So that'd give me -4 cubed minus 2 times -4 squared minus 13 times -4 plus 26 equal. And figure out what that is. So -4, that'd be 4, 16, 64. Negative. And then that'd be 2 times 16, that's -32. Ooh, that's going to be positive, and that would be 40, 52, 26. Oh, man, that's going to be -96. -96 plus 26 would be 70. -70. -70 plus 52 would be -18. All right. So f of -3 will be now -3 cubed minus 2 times -3 squared minus 13 times -3 plus 26. That gives you 3, 9, 27, 18, 39, 26. There we go. So that would be -45. Yep. And then that would be -6, and that'd be +20. All right, so therefore, 2 different signs, so the answer is yes as well. If you get different sign or same sign, then the answer is no. These all happen to be yes. And that's kind of really all your homework was talking about. We kind of hit everything in it. We just didn't really talk about Descartes' rule of sign, and neither does your homework. So I'm thinking it's just a topic that doesn't have to be taught, but it's always good to know. Until the next video, see you then.